Okay, am I live? Am I live? I forgot to see how much disk space I have. 16 gigs. Okay. Uh, see if I'm live yet, and then we can start. Okay, we're live with unstable bitrate. Okay. So today's stream, right? Today's stream, I'll be adding tools to my Infinite Canvas application that I'm using for learning methods. That is based on cognitive science, research. And so I'm going to start doing that. Last stream, I didn't get through much. I was just pretty dead and looking at the documentation most of the time. And I have a bit of a flu, so I apologize for any sneezes or bad audio. Okay, so it's been 2 weeks. So I've kind of like, wait, did I even? Oh no, I'm still cam only. Main. Okay, let's transition. Wow, look at that. It took me like 2 hours to find my green screen, but I finally found it. So currently, all we're doing, and let me show you the current state of the application and mapper. It is made in Raylib currently, and it's optimizing anchor points. So you can see right here, this is only 45 anchor points, even though there are a lot more frames. And I can go really fast. It's also detecting that each stroke is different, so it's coloring it differently. And I need a few more tools. I have a few more ideas. One of them is that I want to be able to draw a square and it be turned into a perfect square, and that should be an option that can be turned off and on. Another, same with circles and triangles, and you get it. Arrows. Uh, I want a text tool as well. I know that's going to be difficult. Uh, But yeah, for now, I just want a select tool for this stream so that I can select these strokes and move them around. I actually forgot to pop up my chat. So let me, how did I do that? How did I do that? Boom, pop out chat. Okay. Oh no. Uh, this can be very thin, and this can be the size of the screen. Let's go Neary. So we can close that. Okay. I will eventually, I might make this hot reloaded, but not right now. So in any case, we're here setting the current tool. I've also seen here that I'm using a stud optional and then a reference wrapper to get the current stroke. I'm not going to be changing that right now. What I am going to change is how I'm returning these. So there, if you go to like, for example, learncpp.com, that's very interesting. I don't know why that happened. If you go down to const, returning by const ref. So these are ref qualifiers, returning by const ref, right? What? Just because it's an incognito window, bro. Learn CPP ref qualifiers. Okay. No, no ads. At the end of this article, I think, here it is. While ref qualifiers are neat, there's some downsides. Adding R value overloads to every getter that returns a reference adds clutter to the class. And okay, this was one. Meh. We are not recommending the use of qualifiers as best practice. Instead, we recommend using always the result of an access function immediately and not saving or returned references for use later. So burden on the programmer, but let's just do that instead. So here, when I'm returning a tool is basically an enum, so I don't have to return this by const reference. But something like a stroke does need to be returned by const reference. Stud optional though, stud optional. And this is kind of redundant because of return value, what's it called? something with an E. Elision. Return value elision. But right now we don't need to worry about that. Let me just see. Okay, yeah. So what's next? How do we actually get the current tool? So here I've done a get current tool, and I have a tool enum, which is the brush and the selection tool. It's a member variable. And depending on the tool, we want to do something different. So that would be in the update loop, I think. So if I go back to main CPP, this needs to be zoomed in probably for everybody to see, and eglot, let's run that. Here, this only makes sense is button down and is button release to app.add anchor if you're in brush mode. So I think we can switch app.get current tool, and based on each of these cases, let me make sure I'm doing the right thing. Okay, so it's just kind of like Java. So switch case. I don't know why my indenting's all off, but it's going to be tool dot, whoa, tool colon brush. Then we gotta do that. Why is it being weird? Why is it being weird? Why is it being weird? Enumeration values selection not handled in switch. Yay! So it does tell you that. I was just thinking about, you know, and so we don't want to do that if we are on break. What I don't understand is why it's not indenting region properly. Please indent the region. I guess it's just like this. Let me copy that, and we can stop stroke. So, okay. So if is mouse button down, we can either A, select it, or we can grab it, right? So if the mouse button is down, we can tell it that we have started dragging, but I also want to be able to just click and select. Because that would be like, if I slightly moved my mouse while clicking on it, I think we can do something about that. But right now, let's just be able to drag it. So if mouse button is down, let's get that stroke. And also, how am I doing this right now? I have a vector of stroke IDs as my selection, but for my strokes, I'm actually referencing it in vector. The problem with this, right? The problem with this, how am I doing this? So I'm getting the strokes as mstroke as a const vector stroke. Yeah, I've completely forgotten my code base, so let me just think about this. What's happening? Get ID, get color, get anchors. How am I getting a stroke? And okay, this will just get stroke with an index. And how am I looping over them? I'm looping over them by just getting the strokes and for each stroke in strokes. The problem with this is, yeah, any reference to that needs to point to stroke. Will the cache lines be warm after that? So I'm not really sure, because if, let's see, let me think about this. M strokes is a list of stroke vector. M selections can't really be a pointer to that, and nor a reference to that. So instead, we're just taking an index. Here, we're just looping over all the stroke on our strokes. Okay. Hmm. So here was the primary contention. Since our strokes is just a list of vectors of proper objects that have been instantiated, stroke ID, of the vector with stroke IDs, I can't really visualize this well. Let me scally draw this. Let me theme dark. So we have our main list of strokes, right? There's going to be strokes, and that's going to point to memory, which is going to be proper, stroke objects. Then we have a selection array, and that would point to just IDs, right? I point to IDs, and that would be something like this. Is this problematic? I don't think so, but let's see what's up. So when I click on a stroke, I want to see if do I have to do collision detection for this? So I have to see where my mouse is intersecting with each stroke, but the anchors for each stroke here, the anchors for each stroke. So I'll need to see if they're in the range of which anchor they're closest to. That's going to be very expensive. Which anchor they're closest to? Hmm. Because that should see which anchor they're closest to on all the possible strokes. Then we can chunk that and then we can optimize that. But I think this is going to be the main starting point. Okay. So if you have your standard vector anchor, just a list of anchors, each stroke has their own list of anchors. I'm going to have to loop over, here it is. So I'm going to have to loop over all anchor points. Where is it? Const auto strokes. Const auto strokes. That's going to be app.get strokes. And once we get the stroke, we're going to say we need a const stroke reference from each stroke. Uh, okay, whoops. A stroke reference for each stroke. And then I'm going to loop through all anchors, but I'm already doing that when I'm rendering it, so it's not really that big of a deal. I get the anchors, but then I think yeah, I already looped through all the anchors in my render, so let me do that again. But this time we're not going to be drawing any circles, we're not going to be drawing any lines. It's purely size t all the way up to anchors.size -1 and I++. The thing is, we don't need I for this. We can get away with just using normal anchors. So anchor, reference anchor, and then for each anchors, right? There's a const auto reference. Where is this going? I don't understand why it's indenting like this. We are going to have to check if our mouse anchor, and this will return an anchor. And remember, our anchor is our Rayleigh vector 2. which is just a struct with a float x and a float y. We have to check if our mouse anchor is because what if they're different brush sizes? Then each anchor will have to, but that will be pixel perfect. So we could have like a bounding box around our stroke, which could just select that. And we could manually update that bounding box. So we have multiple options. How do we do it? We have multiple options. First is, let's see how Xcali does it. So when I click on something, even if it's overlapping, okay. It's not, okay. So it is kind of pixel perfect. Look at that. And I can grab this through that. It is pixel perfect. So that we can actually just grab anything. Not really sure on what to do about that. So we have option A. We have option A, which is to just do the bounding box. Or B, we do anchor points with each anchor must have a brush or like size, basically. How thick was it? Since I'm not going to be supporting like other types of brushes like calligraphy brushes or anything, I think this can end up simple. But storing, and that's why Excalibur probably has like 3 types of stroke widths, so that it's pretty simple to store. But I really hate that. And the thing about it is when you have infinite zoom, and when I draw with any size, that also needs to be calibrated. So I think we are going to draw with zoom or size. That makes more sense for infinite zooming in all directions. So we're going to go through with our anchor. The problem is anchor is just a vector too. And that's simplified a lot of things. For example, we could just simply pass anchor to here. Let's see. Get anchors. Where is it? Where did I use anchors as vector 2? Here it is. Anchors at I plus 1 dot x, and we still had to static cast that to an int though for each one of them. But we could do like start pause of I. So what we can do is have anchor be our own thing. So there's going to be a class anchor and private or should I just make it a struct and make everything public and not have to worry about so let's do a struct. And we can always cast it to a vector too. So float x, float y, float size. And so we can always just cast it to the first two. I don't have to worry about padding. This is pretty good. And wait, stroke ID is just size t. Interesting. What's happening here? I haven't put this. And let's see what errors pop up. So compiler-led developing. A lot of errors, apparently. The first of which seem to be about mouse anchors. So let me remove that. Whoops, something like that. No declaration matches standard optional. Oh, because I changed what's it called? State.cpp config brush size. So result of integer division used in a floating point context, possible loss of precision. Okay, here it is. So const, all I need to do is just reference and reference here. What's happening here? Returning a reference to a local temporary object. Am I? Just a second. Okay, where was I? The stream still working. Stream is still working. Oh, okay. Here I'm doing what? Whoa, what was that? Did my green screen just fall? Okay, no, it's good. Um, what's happening here? Returning reference to a local temporary object. So mstrokes dot add index. Um, this does a rain check and then returns this as a pointer. And we're trying to return that as my brain's not working. What is this? Returning reference to a local temporary object. How is this a local temporary object? So wait, if I didn't do that, that would work because I'm copying the stroke. But I do not want to be copying the stroke. Instead, we're checking. Wait, why are we checking that if it's already going to be checking it for us? Yeah, this makes no sense. Oh, because then we can return an optional. Then why are we range checking this then? This should be more about like this. Still not returning this by a local temporary object. Instead, I'd have to do something like so I have to construct the object. Oh, because I'm returning the optional by reference instead of just like making it a reference wrapper. I'm kind of hating optional right now. I'm kind of hating optional right now. I'll do it anyways. So like we're doing a reference wrapper stroke, and let's see how that worked. Is this working? No viable conversion from return type value const. Oh, whoops, this const. Okay, this is still problematic. I wonder why. Thing is, returning the stroke by reference is also kind of weird. Because if you think about it, returning a stroke by reference. Bro, it's been 2 weeks and all of my CPP knowledge has gone out the trash. Why did I write it like this? Why did I have to do an optional before I just revert back to nothing? The only other option would be exceptions. The only other option would be exceptions, and I don't think I want to do exceptions. But we're doing a reference wrapper. Because if we're getting the current stroke, I don't want them to be able to, like, you know, change it. So this needs to be const. Same with this. This needs to be const. This can also be const. Uh, 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 because now we'll turn m strokes as index for reference blurs. The function return type, so reference wrapper const stroke to let's see if this okay. I do need to like actually build it like that. How did I do it again? Why is this crying? Get current stroke. So let's say because this is returning a reference. Um yeah, and if I const this, yeah, it's working, right? I'm just returning to m strokes back. Here, I'm also just checking if index is less than and index is greater than m strokes. Oh, sorry, greater than 0. Then we can just return m strokes index. Otherwise, we want to return this. Or we could do m strokes dot at index and then try catch that. I think that would be something as well. So we could try doing this, and then we could catch exception e, right? Constant optional reference wrapper, and so we're going to std ref this. What is the issue? Oh my god, bro. I'm coming back in. Okay, let's hope this green screen doesn't fall on me. It doesn't. It seems to be falling on me. Whatever. What is the problem with this? M strokes index, no viable conversion from returned value of type reference wrapper, const stroke. Oh. Oh, okay. My bad. My bad. My bad. My bad. My bad. This is what needs to happen. It's crying, but this says this is what needs to be at. This is what needs to happen. And so at index can actually work. So this is gonna throw a range check, throws out of range if the check fails. So let's be out of range. So let's be specific to that. And then we can just return that instead. Um, even still here, we can do const stroke instead, and we don't need to do const here. Thing is, why can't this just return const? Oh, it can. Okay. Uh, should we return? So let's ask that. Should we return in C++? Should we return the reference wrapper is already the stroke in the reference wrapper is already const? Should we also return stood optional by const? Should we return stood optional by const? Okay, interesting. Uh, Are we actually trusting the clanker, or let's just see. Is a good place to use std optional instead. Okay, use std optional as to represent emptiness. Okay, as a return value when it's possible that the function cannot return a value. For example, when they cannot fetch URL. Of course, production code fetch URL might want to return error code. Be asynchronous. As an example, don't use if you want to pass a pointer to an object that may or may not exist. So which is what I did. So why shouldn't we do that? Don't use std optional if you want to pass a pointer to an object that may or may not exist. Use a pointer instead. By definition, a pointer may always be null pointer, so it's already optional. I feel like if you think you need an optional reference, you should probably be using a pointer instead because a pointer is already an optional reference. Always pass std optional t by value because it's a value container, especially. And that's got returning t pointer implies that object ownership has not changed, implies that I now own that object. Interesting, because we're technically creating a copy. And so doing a std reference is kind of goofy. If you are creating a code base with a lot of C or legacy C++, generally I would pass it by value if you have passed T by value, and by reference I would pass by T by reference. Okay, so yes, we are going to want to change this to be like a const stroke reference. And we don't even want to do all that. Yeah, that was so goofy. So const stroke reference. And we can check. No, but a reference can never be. Okay, so this is the problem. The pointer thing I don't really agree with. But if you're returning by reference, this can be an error, and then using std optional as basically the error. But I do agree that it kind of implies ownership. Instead, should we just let it throw an error? Let's let it throw an error for now because I'm not that advanced in C++ right now. So let's see. So get current stroke. Mm, you see, this should return an optional. Why can we put stroke? So we have const reference wrapper. Yo, this is so goofy. Handling C++ errors in any other way other than percent. Or actually, you know what? Let's just when are we? It said we'll talk about there are 4 general strategies that can be used to handle the error within the function. Pass the error back to the caller to deal with, halt the program, or throw an exception. Handling the error, if possible, the best strategy to recover. Okay. Retry until successful. Cancel the operation being executed. A reference cannot be null. So here we're just doing this, which I agree with. Get stroke, however, should not be empty. It should throw an error. So let's do that. It should throw an error because then we just can't return the reference. Let's see. But this quite literally is like we don't know, right? And this is a reference wrapper, so no, we're not passing ownership. Yeah, okay, I agree with this now. Let's do this now. So get current stroke as this instead, and get stroke now doesn't need to be an optional. Okay, this looks kind of clean. Cleans maybe an overstatement, but it is what it is. Bro, I'm feeling this is so hot. Add anchor. Get current stroke dot value dot get dot add anchor. Anchor. M is drawing is true. And here when we stop the stroke, M is drawing is false. Uh over here, let's see what other errors we have. Okay. So here's the main error. Could not convert, the anchors at I. Let's try and okay, could not convert aka const anchor to vector 2. Could not convert. So we could do like a cast it, or we could have a function to return it as a vector. We could have a function to return it as a vector. So vector 2 as and the name is going to be as vec2. Uh this should be generally null discard, and this can return it as a vector 2. So return x and y, and that should be positive. Okay, I like this. I like this. I like this. And then to get anchors, we can overload it as like a vector of vector 2s. There's as vec2. And we can do some performance optimizations on that, but basically, actually, let's not even do that. So where are we actually facing the error? Draw line X. So here, anchors at I is a start position, because this needs a vector 2. So dot as vec2. Why can't I run that? Because it's a pointer? Is that it? Not even a pointer. As type const value type, aka const anchor, but function is not marked const. Oops. This should be const. Okay. Now this is nice. Draw line X, draw line X, strokes dot back dot get count anchors dot back. What did back do again? To the data, the last element of the vector. Okay, and then we can ask vector 2, get mouse position, and everything's good. Okay, now app.config.brush size, I don't think this is not like a configuration thing, right? It's more of like an app state thing. And that will be more of our current zoom level. So that will be eventually our current zoom level. And then our brush size. I'm not going to be playing with that right now. Or should I? Because if each anchor, I think that's fine. Because then when you're actually creating a stroke, you're creating it with the current. So you know what? Let me go ahead, go to config. Let me first see if there's any errors right now. Actually, this has a compile in it, right? So compile, and then I can just actually click on this. So no viable conversion from vector 2 to float. Okay, so this doesn't need to be. Ah. So we can make that an anchor by doing by breaking apart get oh no, const. Yes, instead of okay, I have one more idea. So I can just do this mouse pause, and then there's going to be a vector 2 add anchor. Mouse anchor is actually going to be mouse anchor is actually going to be something like this. So dot x is equal to mouse pause dot x, dot y is equal to mouse pause dot y, and then size is sorry, dot size is going to be equal to app dot get current size. I feel like so app state should have its own size. It can be a float, and we're basically going to say m brush size or anchor size, whatever. So brush size app dot, and we need to get the brush size. So get brush size, and that should be a float. And we can copy that to state.cpp when we're getting the current tool. We need to return m brush size. Why is that giving me an error? Because I didn't do app state. And now we have something that can get our brush size for us. And so in our main.cpp, when we add that, we can get our brush size. This can be indented. And so now each anchor actually stores that. And so we can actually go into config and remove the brush size. So this is going to be this size t and then brush size 4t. And so this is diameter. So diameter, and we can initialize that to 40. Let's initialize that to 40. State.cpp. Now when we're creating a state, now when we're creating our app state, we can do this. Control Q, Control J, M underscore brush size. This can be 40, 40F, I guess. Please. Okay. That should be good. And then now let's see the problems. A lot of problems. Let's compile it here. So it's saying that first of all, construct config has no member name. So where are we doing this? App config dot brush size. This needs to be an app dot get brush size instead. And we can actually copy this to everywhere. Okay, I guess this is a lot of places. So let me do that. Let's hit compile again. So now mouse anchor isn't really working, but stop stroke also needs an anchor. So let's create this into its own anchor. Const, not vector2, but anchor reference to mouse anchor. And this is going to be something along the lines of this. And so now we can actually do our mouse anchor, and this should work. Apparently not, because where even is that? Okay, so here, okay, this is interesting. Ooh, this is not pretty. Well, if we're adding an anchor to a stroke, we know we're already drawing it. So it is, and this is since performance optimization, I think it is safe to assume that the actual brush size would be what our app is. And so we could pass in our app by reference, but if we add an anchor here, what are we actually calling this? EGOT uh hmm, add anchor, right? Okay, so our app state actually takes in an anchor, and then our app state takes in an anchor. It makes sure that we're not getting that get current stroke or so we are drawing and we are drawing. Then we're going to create, if not, then we're going to create the stroke with our anchor. Otherwise, we're going to start doing this. The thing is, anchor will always contain. So you know what? We can just use the current anchor size. I don't think, I think that's safe to assume, right? The current anchor size is probably the current anchor size versus anchor dot size. It's probably the previous anchor size, probably the current size of the anchor. So meh, I feel like that's pretty good. And now let's see what if we can compile this. Yay! And let's run it, right? So works works beautifully, works absolutely beautifully. We can still, what can we still do? What can we still do? The funny thing is, anytime we're actually using the brush size or the actual size, we're dividing by 2 anyways. So I'll see if I want to change that to radius, but for now it's pretty good. That's pretty good. That's pretty good. Good, good, good. Das ist gut. Oh my God, it's so hot. Yeah, let me move this to the back. It's dying. Oh, I'm leaking my room. Uh, no. Okay, I'm actually destroying everything. Okay. That's so goofy. I don't know why I have to keep it like that, but it is what it is. Um, now I can stop looking like a chud who's in the heat. Okay. Let's see if the stream's still going. Okay. Now, since we have optimized our stroke, actually, let's print our anchors to make sure that we have done that. Where even am I? I'm cooked. So let's make that a different color. Stroke.get color. Here we're drawing the. Okay, here's the line and here's the circle. Okay. So we are going to do raylib white. Come on. Come on, come on, come on, come on. No? No raylib white? Why not? Okay, I think we can just still do color and then 255 complete white. Let's see. Whoops, I didn't compile it. Okay. Yeah, so we do that and then we do that. And we do that and then we do that. And we do that. Makes sense. Boom. Now what we are going to do is actually get the tool working. So I've just been refactoring till now, but now we can actually get the tool working. I mean selection working. So we have a M brush size now, and we're using this brush size to create anchors by default. And each anchor knows what size it was. But it's kind of weird how drawing instead of drawing with the anchor size, we are anchor.size, we're actually drawing with our brush size. Is that weird? Or am I tweaking? Is that weird or am I tweaking? Because look, we're getting the brush size to draw the circle at the start, then we're drawing a line, and then a circle, our next anchor at the end. And we're just giving that our brush size. Who's actually setting that anchor? And it's us when we use it to do our get brush size. Okay, I think it's fine. Uh we'll see. So case tool selection. Right then, we move through each stroke, we move through each anchor, and we just want to see if our mouse is hovering over any of the stroke's anchors. The problem is that multiple anchors are possibly overlapped. Where is my Excali draw? It's here. So it could be that anchors going this way, right? And we have anchors going this way. Now, if I put my cursor right over here, is it going to choose the red one or the white one? And to solve this problem, we need to have depth. We need to have depth, and depth is so should each anchor also store its Z? And Z is not just zoom, it's also where it is. So that's pretty interesting. But we were already keeping track of which one is which by going through the strokes list, and stroke was already in the order of depth. And then we just need a zoom for each one, but we're not implementing zoom right now. So this seems interesting. You know why? I think I know why. I think I know why it's interesting. And it is definitely interesting because I said so. What should we do with this? We can go through reverse. So does this support reverse iterators? Probably not. We're going to have to do it the other way around. So oh, but we can do strokes dot reverse. So but that's gonna be slow. So let's do uh const auto. This is probably gonna be an iterator, and that's going to be strokes dot not cn const iterator n. And we are going to, as long as iterator is less than strokes dot begin or greater than begin iterator plus plus. Sorry, minus minus. No, because it's const. It's const iterator. That's why. Why not? Cannot decrement value of type const iterator. Oh, that seems interesting. But we can do this though. So what is the difference? What does it mean for const iterator to be const itself, C++? That's a pretty interesting question in my opinion. So const iterator provides read-only access to container elements, and that makes sense. That's all I need to know. This is just marking the iterator as const. We don't need to do that because we are actually decrementing it. We want strokes.cn and cbegin because we don't want to actually change what we're pointing to. We can do iterator. Iterator dot base. Is base it? What is base? M current. So C++ iterator base. There is a std reverse iterator. In C++, iterator base usually refers to one of two different concepts depending on the context. The dot base member function used by iterator adapters or the deprecated std iterator base class. And move iterator wrapper regular underlying forward iterator. The base returns a copy of that underlying base iterator. No, we don't want that. Iterator get current value. Oh yeah, my bad. So iterator get anchors. What's interesting is reverse iterator though. So reverse iterator. Let's see what that's about. Where are the examples? Okay, so here we're doing this, and then we return a std reverse iterator. And then we can just do that. Iterate reverse. I want to see if there's any better way of doing this. Iterate reverse C++, but using a for each. Okay, there's views reverse. Syntactically identical to standard for each rule. But is it actually like this will, but this is lazily evaluated. But it's being used immediately. So is it going to first reverse the entire thing and then do that? What's actually going to happen? You can use standard for each combined with reverse iterators. Using that. Or, oh, you can do R begin and R end. R begin and R end. Let's do that instead. Where is it? Where is it? Where is it? Oh, it's here. So R CR end and CR begin. And we can iterator plus plus is not equal to numbers dot rend. So CR end. So CR begin. Because technically it's okay. And then we do that, and then we dereference to get the value. Okay. So we're gonna get the anchor. So we're doing it constant and reverse. And this is going to find the first thing that we're overlapping, and then it's gonna quit. It's gonna find the first anchor that is overlapping, and then it's gonna return the stroke. So first thing that it's overlapping. We can do this by doing anchor.size, and we can say if our mouse anchor.x is greater is less than anchor.x plus anchor.size. Okay, this is kind of confusing. Let's pull out some CaliDraw here. So here's our thing and here's our pointer. Okay. So let's see. So this, if the x pointer, if the x for Raylib and 0, 0 is at the top over here. 0, 0 is at the top over here, and x goes this way. So x goes this way, y goes this way, right? Raylib towards. These 0, 0 is top left. So its x needs to be less than anchor.x plus anchor.size and mouse anchor.x should be greater than anchor.x minus anchor.size and mouse anchor.y should be so its y should be less than this. So it should be less than anchor.y plus anchor.size and mouse anchor.y should be greater than anchor.y minus anchor.size, I think, because we're getting its y and it should be greater than this minus the size. Yep. Or we could just check the distance to the anchor.x should be less than this. I didn't even need to do all of that. Mouse anchor, so std distance, no, high on pod news. We are going to std high pod. Let me see if the stream's still running. It is running. High pod between float x and float y. Between just 2x and y. Yep. So that's going to square and find the distance between. No, something's not right. What does standard high pod do? Compute the square sum of the x and y without undue overflow. The hypotenuse of a right angle triangle is returned, right? So it's just going to return the hypotenuse like this. I want to subtract distance between point A and point B is this. Oh yeah, okay, I'm goofing up. A dot x minus b dot x, so we can just go there. Where is it? So mouse anchor dot x. Should that come first? Since it's square root, it doesn't matter. So mouse anchor dot x and then anchor dot x and mouse anchor dot y minus anchor dot y, and the square root, this will always return the positive one. I want to see. I want to see. Uh, is equivalent to std fabs is called with non-zero argument. So I feel like it doesn't matter. So we're going to take that and we're going to check if that is less than anchor dot size. And if it is, it means we're colliding, right? Does it need, okay, we need to refresh eglot. So if it is indeed colliding, then we can just select that and then break out. So we can return the current stroke. So iterator, just return iterator, just like that. And this entire thing, all it does, it just returns the overlapping. It returns the void app. Okay, where should this be placed? This needs to be somewhere like here. So app.add anchor, and that just did some basic checks. Just like that, we need to see app.select, app.get get hovered. It should just select it, right? So instead of just returning this, it should add it to the selection. So select, not like that, app dot add to selection. So there needs to be a set current tool, then there needs to be a void set selection, and this needs to be a list of so instead of passing an entire std vector and then maybe optionally creating that, I would maybe overload that later, but for now I can just set it to a single stroke, right? Right. We are not going to be changing your new tool, but we are taking it by values. It doesn't matter. Con stroke reference is going to be our stroke, and that's going to be our set selection. And then we can do an add to selection, and that is going to add the stroke to the selection. So M selections. So let's create these two. We need app state in front of stop stroke. And let's see. So we're gonna set our current. We're gonna set our current selection. M selections. M selections dot clear. Is there like a what does erase do? So uh empty C++ vector and empty the C++ vector and place new in place new object. Clear followed by in place back. So it is that. So we can clear it. And then M selections dot what was it? We can in place back, but we can also not back. Push back. push back stroke dot get ID. And just a second. My bad. My bad. My bad. Okay, I guess that doesn't show in the main one, so it doesn't matter. 1 hour, 14 minutes. Okay. Broke my flow. Where was I? So set selection. We clear the selection, then we push back the selection, and when we're adding to the selection, we just push that back. It's not really that complicated. That's about it. Okay. And so we can go to our main.cpp and then see that, okay, so this is now doing this. We can add it to the selection or basically set selection to our new stroke. Or in this case, it will be dereferencing the iterator and then just breaking out. So breaking out actually, now returning. That should be chill. Let's see if it actually, oh, but we don't have any way to see the selections. We can then, after we've drawn all our strokes, and is this our phantom stroke? If strokes is not empty and strokes.back.get anchors and our last stroke is not empty, if our stroke is not empty and our last stroke is doesn't have 0 anchors, then is mouse button down uh what? What is this? Oh, this is looping over all the strokes, and then here's one which we're continuously drawing. So this will just continuously draw it at our mouse position. And if it's held down, it will draw a line from that to this. Okay. This is just basically phantom stroke, right? This is all phantom stroke. Phantom stroke should be on top, but only if we are tool selection. So if app.get current tool is tool brush and then all these things, then that makes sense. But if app.get, but regardless, I think it doesn't matter whichever tool we're in, we should always draw the selection. So let's say I select this and then I go to brush. Okay. So all our selections are reversed. So I think this we can reuse like a switch case even here to see the tool. App.get current tool and so we can do this. Oh no, what am I doing? Case tool brush, and we can remove that, and then we can break, and then we can case tool selection rather. And if we are doing a selection, we don't want a phantom dingleberry being drawn, but instead we need to go through our entire selection over here. So when we're going through the strokes and we're actually going through drawing all the strokes, we want to like draw a bounding box. So let's say we have a stroke like this. Whoops. Say we have a stroke like this. Its bounding box needs to be like this with some padding apparently. How do I add this bounding box? This will need to calculate the bounding box. I think we can store it right after the stroke is made for performance optimization. So this needs to be like part of the stroke. So state.h, part of the stroke. Part of the stroke. So here, m index, mid, m index. Okay, this is just a static to create your own ID. M anchors. So that's a std vector anchor, M anchors. And then we have our own color with each stroke. We can make each anchor a different color, but we're not that advanced and this is a simple application, so we don't need to do that. So there needs to be a bounding box. And for a bounding box to happen, it needs to basically be a rect. So stroke bounding box needs to an M bounding box, right? And this should actually be using a rectangle, right? Because if you go to that, X, Y, width, and height, right? And as soon this should be by default, it should be when we're when we are we don't have a stroke, we need to create that bounding box. And so will that bounding box be automatically updated? I feel like that we don't really need to do that right now. So we can do that every time we add an anchor, or we could just set it when we stop the stroke. And let's see what happens when we stop the stroke. Get current stroke, dot value. Yep. Get current stroke, dot value, dot get, dot add anchor force. And then we're adding an anchor, and then we're setting M to be ball. Huh. So we should technically be updating it every anchor. And we can make it procedural. So we can check if the bounding box already. We can check if each anchor increases the bounding box, or is it still inside the bounding box. So if this anchor position is outside of the anchor box, and so it can be 0, can be negative the rectangle, the bounding box, where is it? Here. This, I feel like it could be stood option. And so M bounding box, right? If its width and height are 0, 0, we can do that. So state.cpp here, when we're adding our first anchors and colors and everything, we also need to be seeing if M bounding box can be 0, 0, 0, 0, right? No matching constructor for initialization. Boom. That should be everything. And every time we add an anchor or add an anchor by force, we almost need to, this is also like a private function. We need to update the bounding box with an anchor. We can do a should update bounding box and then an actual update bounding box. It could, okay, so that should be inside that. If it needs to update it, it will. If it doesn't, it won't. And I think that's pretty cool. So it would just, let's see, stroke update bounding box, const anchor anchor. So here we will check if bounding box dot width is equal to 0. And honestly, that's a pretty good check just by default. How is it with 0? If so, that's the no bounding box. No bounding box. We can then update it, right? Or or anchor. So this is no bounding box. This is if it's outside that. So I want to see if Raylib does support that. So I want to see if Raylib supports rectangle operations. So rectangle get shapes texture. Should check if it's so we're gonna be checking collision between rectangles over here. So we're gonna check if there's no bounding box, and if there is a bounding box. So let's see. So the old bounding box would be this is the old bounding box, and let's say we made an anchor here or here. Is this x and y, right? Is this x and y greater than x plus width and x plus height, or something here? Is this, is this outside of that? So I think checking, because we don't really want to check circle collision, because this could also count as collision. We want to check between 2 points. Let's see that. Let's see collision. Check collision between point and rectangle. So this is P. Check if a point is inside a rectangle. And so we can just do that. So check collision between point and rect. And so in this case, vector to point anchor dot as vec2. That's a very useful function now. And rect thing is, this is going to be returning a copy for each and every single vec2. And we're returning a reference to a local temporary object. Instead, if we could just cast this, we could somehow cast this. as why not? Const anchor pointer to vector 2. Really? Okay, I guess not. We're gonna have to go with that. So anchor as vec2. We're gonna check if this is within the rectangle M bounding box. And if any of those is true, which means either there's no bounding box or so check collision returnable or not collision, right? Then we need to update the bounding box. And so bounding box, we could loop over everything, or we could just see which direction it went through and then update that. How complicated would that be? That would be saying, okay, this point is here, and so increase the width, decrease the x by this much, and increase the x width by the same amount, and the y. But if that's signed, here we just need to increase the width. I think we can recalculate the entire stroke. So bounding box for the entire stroke, unless we have performance optimizations. So M bounding box is now going to be equal to, and so we can set that. So let's set that state.h, please. Okay, it's goofing up. Here we want to get anchors, you want to add anchors. Let's set bounding box. Set bounding box is definitely a private function, while update bounding box is definitely a public function. The set bounding box is going to be const and to just a new bounding box. New bounding box. Okay, and let's just go ahead and make sure that this function is actually existing. We can set the M bounding box to new bounding box, and we don't really need to check that hard because it's a private function, but at the same time, we can do that. So set bounding box to be our new box. And that's problematic because we need to calculate our new bounding box. So stroke bounding box, we need to go through each anchor. Here we said we should need a rolling one. So yeah, we need to check. So for anchor is so if anchor no if anchor dot what a bot, bro. Like even using the fonts, that's so crazy. If anchor dot x is less than there's two ways of doing this. Every time something happens, every time these anchor points are made, we can just recalculate the entire thing and say that, or we could have this and then we could see, oh, is this new anchor point? So if it's on the outskirts like this, there's only 9 real possibilities, but 2 of them are simplified. So regardless, if it's to the bottom right, we need to increase our width and height. If it's here, we need to decrease our x and y and increase our width and height by the same amount. So if they're if they are, so if the anchor dot x is greater than our current bounding box dot x plus bounding box dot width, does Raylib have like a bounding? Ooh, get collision boxes between 2 bounding boxes. No, no, I'm fine. So if our anchor, what am I doing? If my anchor dot x is greater than m dot bounding box dot x plus width, then we need to increase m bounding box dot x, sorry, dot width plus is equal to anchor dot x minus m bounding box dot x. This is we're doing it way too complicated, you know. We should just loop over each anchor in the stroke, right? In each of these. We should loop over each. What does this do instead? Okay, so it turns the anchor. We're going to get the anchors. We're going to loop our anchor through each of them, and we're going to basically record our problem with anchor is its float, and rectangle is also float. Okay, so float minimum. It needs to be like minimum anchor x, right? Minimum anchor y, and same thing with maximum, right? Max. And so we can just go ahead and see, is our anchor less than minimum anchor dot y? I guess it will be the same complication anyways, because we'd just be doing that in a loop. We want to see, or we could just do be ultra non-performant and just do a minimum, like stud minimum between get anchors dot, and then we can just like assign that to something. Yeah, I feel like this is fine. So if our anchor dot x is greater than m dot bounding box dot x plus width, then m dot bounding box dot width is going to have to add to the difference between that. And if anchor dot y is greater than m bounding box dot y plus m bounding box dot height, then m bounding box dot height going to have to equal anchor dot y minus m bounding box dot y, right? And then we have to change its x and y. So this is the only way we're going to do that, right? If anchor dot x is less than m bounding box dot x, then we just need to say m bounding box dot x is going to have to equal anchor dot x, and m bounding box dot width needs to have to plus equals the difference between m bounding box dot width and our anchor dot x. So you see, I want to make sure this is positive. So if our anchor dot x is to the left of the bounding box, I want to make sure that the x, this is the difference, right? So the anchor dot x is going to be less than this. So we need to see the bounding box dot x, bounding box dot x minus the anchor dot x. And that's going to give the difference. We want to increase our bounding width by that much. So exactly this much should be increased. And exactly that much should be increased. And then we got to move. We're going to set it to our anchor x. No, but this will we still need to check. Okay, no, we've already checked if it's outside the bounding box, right? If it's outside there, if it's less than this, what's happening here? The anchor can be this. And if, let me write by hand so I don't make a mistake. If anchor dot y is less than m bounding box dot y, then m bounding box dot height must be plus equals bounding box, right? So if it's up, we need to first increase the height by the difference between ry and our anchor dot y, right? Since our anchor is greater, and m bounding box dot x needs to be equal to, sorry, dot y needs to be equal to anchor dot y. That was a lot of raw effort for basically doing Lumbee, right? And so that's automatically setting our bounding box. Setting our bounding box then doesn't even make sense. Because we've just updated it instead of doing that. And basically, if it's not, because if we go to the collision and then actually go into user local libraylib, how do I find implementation? I think I have it in source raylib. And then we can just rip grep for whatever I wanted to do right now. Check collision, right? Yo, please copy this first. And okay. In anything.c. And here it is. So point.x must be greater than or equal to rect.x, and point.x must be less than rect.x plus rect width. And so it checks that and then true. But the thing is, if any of that is true anyways, right? We're already checking each of this, right? So Mm, but we need to check if it's inside before trying to update each of them. I feel like that's fine. It's not putting me. This is the only thing where is it to the left or to the right? It can either be any of these, but it doesn't matter. Finally, we can run update bounding box. Let's remove set bounding box. We don't need it. We can run update bounding box every time we add anchor with our new anchor. And we can do that with our this as well. Yay! And now we can draw that in main.cpp. We can draw what's happening here. Okay. If our tool is selection, we need to go through each of M selected for each stroke in M strokes. So we need to loop over this. And if so we already know it's tool selection. If stroke dot get ID is in stroke, where is it? So app dot get selections. I haven't done that. State.h, I haven't done the M selections. I haven't added getters for M selections. So right after get strokes, get stroke, get current stroke, we need to do a get selection. So of stroke IDs, get selections. And yeah, we can also do like a get stroke selections, and that would just return that, but for now this is fine. Get selections. We can copy this state.cpp and we can do current stroke, and we don't need this. Don't need this either. This should just return M selections. What happened? M selections. This, oh, this needs to be app state get selections. No? What happened? What is happened? Why is this tweaking? Does the eagle need to be restarted? Out of line definition of get selection does not match declaration fix available. Let's see. Mark declaration does not match because it's const qualified. Oh, okay. I don't know why I removed that. Yep. Then here we can just get the selections, and then we can go back to main.cpp, and we can get selections. So selections. Yeah. There's a lot of room for optimization for each of these, but let's just get something working. So const auto reference selections just needs to be app.get selections, right? And so if selections dot contains or selections dot. Is there a beautiful way to check if vector contains element? Find ranges contains. So contains vec. So stud ranges. If stud ranges contains, and we need to do that. Contains. Why? Contains and then entire selections. Does it contain the element stroke dot get ID? And if it does contain that, then we are going to draw the bounding box around it. So draw rectangle, and not this one, not even this one, this one. Draw rectangle rec, which just takes in rec and color. We don't need rotation. Wait, rotation is kind of crazy. So eventually we need to do rotation as well. Anyways, rec takes in a rectangle, so we can just get stroke dot get bounding box. Why isn't there a get bounding box? State dot etch bounding box. Please let me get a bounding box. That can be stroke bounding. Whoops, stroke bounding box. We can const reference that. Get bounding box const. Actually, we can just do that instead and state.cbp get anchors right there, right here. We can return m bounding box. Oh, just like that, we have get bounding box, stroke dot get bounding box. That's our rectangle. And then for our color, this can be configuration. This can be some state.etch configuration stuff. Selection color. And this can be like a selection blue color. Let's do a color picture instead. That's pretty interesting. That's the exact color I wanted. It's also kind of scary. But who cares? Boom. And so we're going to go selection color. So app state config dot selection color. Let's see if all of that code compiles. It shouldn't. Woo! Compiled? No way. First try? Okay, now let's change the selection. Whoops. Let's change the selection. So if is mouse button down, if is key pressed basically. Else if is key. Wait, so there's a is key down. E1, E1. Why not? Why is this not leading me? Is key down? Check if the key is being pressed. Is key up? Get key pressed. Pause multiple times for keys queued. Return 0 when the queue is empty. So is key down? We'll check if a key is being pressed. And check if the key has been pressed once. So let's do that. Is key pressed? And then we do key 1. We can go to the same enum here and then key 1. Yeah, literally the key 1, 2, 3, 4. Then we can just do app dot set current tool to selection. And otherwise, else if key 2 is pressed, then we just want brush. And let's make that and run that. So by default, I don't know why it didn't show it at the start, but okay. And now when I do 2, so we'll go back to brush, still in brush. 1 is now in selection. Ooh. X is still at 0, 0. That's kind of weird. Always stuck at 0, 0. Because it's still selected, and clicking out doesn't deselect it. For a second, it looked like it had a shadow there. Yeah, it's definitely not helping. Hmm. I wonder why. So first, let's make this bounding box draw better. Where is it? Here, this just draws a rectangle. Draw a color-filled triangle, but I want to draw a rectangle outline. So draw rectangle lines. This one. So we already have the rectangle. The line thickness we can get through app state. So selection thick and selection color. So selection thick, let's, oh no, let's find that selection thick. This just needs to be around 5 pixels thick. Can be an int. And thick in main. It needs to be a float. To be a float. So congrats for that. And now I feel like, oopsies. Yep. That's nice. Okay. Interesting. Let's render this uh let's render this regardless. So let's render this regardless. Okay, now it doesn't render it at all. I wonder why that is the case. Const auto selections, app.get selections. Then for each stroke. Okay, because we haven't selected it. Oh, we need to draw this without checking if it contains. Just need to draw its bounding box. Okay, boom. And it extends it by its. Okay, that's interesting. Let's go to main.cp. Sorry, state.cpp. Update bounding box. So when anchor.y is greater than m bounding box.y, we add to the height the difference between anchor.y and okay, plus the bounding box dot height. Same thing here, plus the bounding box dot width. And let's see if that updated it. No, it still does that. So it not only adds, it adds by taking the anchor.y and we subtract the value by the lower box, which is bounding box dot y plus its height, right? We get that lower y, and then because anchor dot y is greater than all of that, we take the difference between anchor dot y That's very interesting. Wonder why it's not working. Okay, first of all, because it is obviously outside, it adds. Oh, it's working. Oh, look at that. So we have our selections working, yo. That's beautiful, 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 beautiful. And it only took me 2 hours. Let's go. Okay, but we have to set that the anchor.x, the bounding box needs to be initialized when there's. I don't want to have to get the anchor count and all of this. So instead, we just want to check if our anchor. Oh my God. So our bounding box is just 0, 0, 0, 0, right? And then here we go ahead, so that's our bounding box. And then here we go ahead and add a new anchor, right? This should set its X and Y to be this. And width and height to be like 1 pixel, to be the anchor size. And we can add padding, and I think that's what this does. Like, because instead of, like, if you just look closely, oh no. Okay, what? It takes an approximation, I think. So I think I'm gonna forget that, but it should do 1, 1. And then it should update the anchor points depending on where it's going. So if there's no bounding box, we need to do something slightly different, right? And else if, you know, so here we just set our bounding box dot x to be equal to our anchor dot x, our bounding box dot y equal to our anchor dot y, our width and height, or actually we can just do this, right? Dot x is equal to anchor dot x, dot y is equal to anchor dot y, dot width is equal to 1, and dot height is equal to 1. Or we can just do anchor dot size. Doesn't really matter. Just doesn't need to figure this own thing again. And so when we make that now, ooh, and look at that. Boom, 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 boom. And we can even go to the very corner and drag it, or go to this corner and drag it, go to that corner and drag it all the way to 0. Just like that. We have multiple. And we can even have a dot. That is beautiful. That is beautiful. Obviously, I need to change the, if I click on something, it needs to select it. Uh, let's go back to main.cpp and let's let this rip. Meanwhile, I'm okay. I would have to leave in just a bit, but before that, we can do this. Go to selection and let's draw one more and one square. Then I can click on this, and yo! Honestly, I feel like that's a pretty good part to end the stream on. And then eventually we can drag this. And if we hold shift, it should do multiple selection. But that's pretty cool. We have multiple tools now. And it remembers the selection, obviously. Look at this. Remembers the selection. And we can just change the selection. Okay, and it should ideally select the first one. Okay, I don't know what it's selecting. It's selecting the... Wait, why did it select that? Okay, every time I click on something, it's selecting the oldest one instead of the front one. I think instead of going reverse, instead of CR begin, let's just do C begin. And let's see how that changes something. Whoops. Okay, and so now if I go and select, it will select this, selecting that, selecting this. Okay, so we'll automatically select the one with the most. There is some annoyance though. Look at this. It's almost double the size. The anchor size? Wait, we could have just checked the position and then set the bounding box's width to be that instead of minus equaling it. Oh, what's up with this? Like, let's say I've got this. Why can I select it here? Can someone explain to me why I can select it here? Why? I'm actually so confused. We're gonna have to figure that out in the next stream, but I think this was pretty productive. This was a pretty productive stream. And well, I'll see y'all. Let me do a goodbye. Zero chatters this time. Interesting. I think the time zones, everything, all that, But well, I'll see you in the next stream. And I hope this didn't eat up my entire drive. Next stream, I think I'll be improving the selection. I'll be fixing up the bugs and making it look nicer, the bounding box. Adding support for multiple selections and moving them around. I think that would be nice. Yeah. Well, see you. Goodbye.